Okay, let's do a factorial ANOVA. This is going to be a 2x2 ANOVA, just to walk you through how to do this, looking for the main effects, look for the interaction. And the example I'm going to use is some made-up data, but it's consistent with stereotype threat, which is a cool field of research in social psychology. And so what we're going to test is this idea that men and women perform differently on a math test, but only when there's this cultural belief that there is a gender difference, and that if there is no belief, or you don't remind people about this stereotype, then men and women might do equally well on a math test, right? So this is something that psychologists have done before. It requires an interaction to understand, and so it seemed like a useful example to walk through. So you can see here, we're opening the stereotypes.sav SPSS file, and there's just a few variables in here. Variable number one is just ID. Then we have belief, which is one of the independent variables. This is whether people believe that there is a gender difference on this test, or whether they aren't thinking about that necessarily. So you can see here, variable number two, we've called belief. I've labeled it belief about the test, and you can look in the values tab by clicking this secret spot in the cell that I've labeled 0 as no stated advantage, meaning people don't believe necessarily or haven't seen any indication that there's an advantage on this test. And then some participants at random were told men are actually better at math, and at this test in particular. Okay, so two possibilities. And then we also have gender here coded dichotomously. And if you click here, you can see that we've coded 0 as men, 1 as women for this study. And then the dependent variable here, score, is their score on a difficult math test. Okay, and that should be all we need to get going. I'll go ahead and go into the data view tab just so you can see we have a good amount of data in here, ones and zeros all over the place, different scores. And if I click this A1 button, as usual, that brings the labels back up. Okay, so let's analyze these. All right, we're going to depart from the compare means option in the Analyze menu, and we're going to go somewhere else. So we're going to click on this Analyze menu up at the top. We're going to go down to General Linear Model, and then we're going to choose Univariate. Okay, so these words might seem crazy. They might seem totally foreign. That's fine. Just know this is where we're going. We're going to Univariate General Linear Model. Click there. And this brings up the Univariate Linear Model window, and we're going to select what our independent variables are and what our dependent variable is. And as you can see, there's a lot of other stuff you could do in this window. We're going to keep it real easy for right now. So we have two independent variables, the belief condition and the gender, we're going to call it a condition, I guess, or groups, gender groups. And we're going to put those into fixed factors. So we're going to move belief in there. We're going to move gender in there. Just know that the first option you have under dependent is your independent variables. Okay, so for us, the very top of this screen is what we care about. These are the things we're just going to get to ignore. And then we'll throw math test score into the dependent variable tab. All right, so we have math score dependent, two independent variables because we have a 2x2, just two variables. And the one thing that you will want to turn on for this is to go into options, and go ahead and just put overall in here to the display means, because we want to get all this information, right? If we want a whole bunch, we'll go ahead and click on descriptive statistics. Okay, so this setting is just going to give us the means, the standard deviations, the kind of stuff that's helpful to break down what goes on in a study like this. Okay, again, lots of other things for fun you could have, other reasons why you might want it, but we're going to ignore that for now and just choose the descriptives for everybody. And click continue, which brings us back to our main univariate window here. Everything else looks fine. I'm going to go ahead and click OK, and that runs the analysis for us. All right, so you can see our design, our 2x2 design. We have our two level independent variables, both of them 2 levels. Next up under that are the descriptive statistics. So we have everything we could possibly want, from overall down to the very bottom, the total. This just means the mean test score when we collapse all the conditions together across all the people in the study. The mean is 4.65, but we also have our cell means, so men who didn't see a stated advantage, women who didn't see a stated advantage, men who thought men were better, women who thought men were better. We have the means in each of those groups, and then we also have we just have everything. Okay, so you'll have everything. And then the thing we are going to pay the most attention to is our ANOVA table right down here. Okay, so this looks a lot like the one-way ANOVA. You'll remember mean square and all the crazy degrees of freedom, but we're going to look mostly at the F ratio and the p-values for the main effects and the interaction. Okay, so here what we see, just by looking at this, we're looking at the main effect of belief is a p-value of 0.412. So we're going to go ahead and say that that main effect is not significant. Just having the belief that men are better at this test doesn't just automatically make people better at doing this test or not. But we do see that there's a main effect of gender, which overall, when we look at these means from our descriptives, we can see that down here at the bottom, it breaks them down by men and women, averaging across the other conditions. The evidence in this study shows that men do better on the math test, scores of 4.98 on average, compared to women, 4.13 on average. Okay, and that's a significant difference. So if we stopped here, we would conclude that men were better at this math test than women were, right? Because overall, we see a main effect, right? If we just did a t-test of the world, we'd see a male versus female advantage on this test. But here's what's important. There's an interaction between the belief that gets made at the very beginning of the study and the gender of the participant, right? So here p is equal to 0.001, so we definitely call that significant. F ratio 11.148, much higher than 1, so we can even see from just that this is probably a significant interaction. And so this means that the gender advantage that we see here must depend on the other variable. Okay, so gender has an effect on test scores, but it depends on whether there is some belief present about those test scores. All right, but right now we don't know. We don't have anything else to really say what's going on here. Okay, so we see there's an interaction, but just looking at this can be a little bit of a mess, so I'm going to suggest you graph this out. So we'll head up to graphs, click on our favorite chart builder, and now, because we have more than one independent variable, we can't just use our simple graph anymore. We've got to graduate to what they call the clustered bar graph. This just means that now we're introducing a little bit more into our graph. So we'll pull that up here. It means we're going to have bars of different colors now to indicate our new variable. And we'll go ahead and just put, what's the best way to do it? So let's put belief about the test on the x-axis, and we'll put gender here as the clustering variable. All right. Now, when you do these interactions, you have a choice to make, and you can put one of your independent variables up here in the corner, one of them down here, and it's worth doing it both ways and seeing what makes the most sense to you when you look at the graph. But what won't change is that your dv is going to go here on the y-axis. All right, so everything is fitted. We have one of our independent variables separating the two sides of the graph. We have our other independent variable separating the blue from the green bars, and all of it is telling us about the dependent variable. Okay, great. We'll click OK and see what happens. All right, so that's a pretty nice looking interaction. And if you look at it, to me, the graph of this makes sense, the way that we chose to put the variables on the axes. Because you could think about this as two studies, right? On the one study, it's just a control condition where you just have everyone take a math test and see what happens. And when you do that, there's no gender difference. Men aren't doing any better than women, statistically speaking. The null hypothesis appears to be what's going on. We can't reject the null hypothesis, probably, given this. For now, you could test that, but we're not going to right now. But if we ran this other study, right, if we think about this condition as a different study, where now we tell everyone at the beginning, hey, men are better at this than women. Now we find this gender difference where men are doing better than women, right? But it's only happening under these conditions, and it's not happening here, right? So what we can interpret this again as is that the men versus women effect only happens when there's the belief, right? Or it depends on the belief, right? So the depends or when interpretation are there. And you can also see that the main effect makes sense. that even if you were to average the blue bars and average the green bars, it would look like a difference overall, right? But you need that interaction to show you that no, that difference is only there under this circumstance, under this condition. Let's go ahead, just for fun, let's graph it the other way just to see how that works. We'll go back up again to the chart builder. And now I'm just going to go ahead and drag gender on top of belief, and it'll replace it. And I'll go back over here and scoop up belief again and move that up to the corner. Okay, so I effectively just switched which variable corresponds to making the bars different colors versus being on the left or the right of the graph. Okay, so I switched those out. Let's click OK. And if you had done it this way, it would look like this. To me, this is a little harder to interpret, but you could see again that maybe men get a little bit of a boost when they believe that the test is advantaged toward them. So you can see here there might be a difference where men are helped out by the stereotype, and a condition over here where women are, they do worse when they think about the stereotype or when they're told about the stereotype. Right? So that confirms their behavior, ends up confirming the stereotype, but only because they were worried about confirming it, right? And men get a little bit of confidence from knowing that people think that they're better at it, right? But again, in the control condition, no difference. So 2 ways of looking at interaction. You can plot them both ways, see which one makes the most sense to you. But the point is, we can tell it's a significant interaction from the ANOVA, and then the graph gives us more info about how it actually worked.